Hello everyone and welcome to the last video for chapter 6. So we're going to talk about 6.4 inverse trig equations. So now we're going to be solving equations that involve our inverse functions, such as number 1 here, 2 arc sine x equals pi. So to solve these kind of equations involving the inverses, first we need to isolate the inverse, get the inverse by itself, then apply the property sine times sine, or sine of sine inverse x, which always cancel out, leaving us just x, or sine arc sine x is x, just like we did at the end of 6.3. So in number 1, I want to isolate the inverse function. I have 2 times the inverse, so that means I'm just going to do the opposite, or not the opposite, but the inverse of the inverse, and divide by 2. So I get arc sine of x is equal to pi over 2. And now I'm going to do the trick that they give us at the top, and I'm going to apply sine. And I'm going to do the same thing over here. So sine and arc sine cancel out, so x is equal to the sine of pi over 2. Well, we know, we're talking about sine pi over 2. Pi over 2 is right here. That's 0, 1, quadrantal angle. And sine is y over r, so 1 over 1. So x is equal to 1. All right, with number 2, I got to isolate the inverse tan. Subtract 4 pi. So I get 4 inverse tan is equal to pi minus 4 pi is negative 3 pi's. Divide by 4. So I get inverse tan is equal to negative 3 pi over 4. So now I apply the tangent. I'm going to continue up here. I have y over 3 is equal to tangent of negative 3 pi over 4. I'm going to get y by itself, multiply by 3. So y is equal to 3 times tangent of negative 3 pi over 4. So draw me a picture. So negative 3 pi over 4 right there. And pi over 4 we know are sets of 45s, so that means that this would be 1, in this case negative 1, this is negative 1, and this is root 2. Alright, so tangent, opposite over adjacent, negative 1 divided by negative 1 is just the number 1. So I have y is 3 times 1, so y has to be the number 3. Alright, number 3. Now I have 2 different inverses. But the difference here is that it's asking me to do sine inverse of 1/2. Well, I know sine inverse of 1/2. That's 30 degrees. And now I can apply my cosine. So x has to be the cosine of 30 degrees. Well, cosine 30 degrees is root 3 over 2. Number 4, a little trickier. Isolate the term with the variable cosine negative 1, so cosine inverse, and then take the cosine of both sides to isolate the x. You will need to use sum or difference formula on the right-hand side. Okay, so what we're going to do, like it says, we're going to isolate this cosine term first. Let me go ahead and make us some room. I don't want to redo that. There we go. That way we only have this question on the screen. So I'm going to go ahead and move the tangent inverse over. So I have cosine inverse is equal to pi over 2 minus tangent inverse of 3/4. Now, right off the bat, I do not know what tangent inverse 3/4. I don't know what angle that is. But I'm going to go ahead and draw me a picture for it. So, and we're talking about tangent, we're talking about a positive value, so we're going to assume it's in first quadrant. And we know that tangent is opposite and adjacent. And this is a 3, 4, 5 triangle. All right, so now anytime that I work out this, I'll refer to this triangle here. Now, it talks about using sum and difference formulas. Okay, so x is going to be equal to cosine pi over 2 minus whatever angle this is. So we're going to use our difference formulas for cosine, and I'm going to call this S and this is T. So remember, that's going to be cosine of S minus T, which is cosine of S cosine of T, and we change the sign, plus sine of S sine of T. Well, let's fill in what we know. Cosine of S, so that's cosine pi over 2. Well, cosine pi over 2 is 0. Cosine from over here, because we're talking about cosine t, so we're talking about this angle that involved the tangent, that'd be 4/5. Now, that doesn't really matter so much because 0 is going to cancel it out anyway. Plus, we need sine of S. That's going to be opposite over hypotenuse at 3/5. Oh, sorry, S, not T. So sine of S, sine of pi over 2, that's 1. Because that's 90 degrees. And then sine of T was what I was talking about with the triangle, 3/5. So when simplifying this is canceled out. 1 times 3/5 is just 3/5. That means that x is equal to 3/5. Okay, going down to number 5. Number 5 is also another question that you're going to need plenty of room for. Hint, since both inverse functions involve x, take the sine of both sides and then use the sine a minus b formula. Now, I did not do the a minus b. I believe this here is a typo. It should be a plus b formula. And you'll see why in just a moment. I'm going to isolate sine. I'm going to move arc cosine over, which makes it from negative to positive. So I've got arc sine of x is equal to pi over 6 plus arc cosine of x. Now I'm going to do the thing that we're talking about. I'm going to apply sine. So I've got x is equal to sine of pi over 6 plus arc cosine of x. Well, we're setting up yet again. We're going to do sine of a plus b, or sine of s plus t. This is going to be s, this is going to be t. Now, yet again, I need to construct a triangle for this one, since we don't know exactly what that angle is. But we're assuming it's positive, so I'm going to deal with first quadrant. So for cosine, arc cosine to be x, x would have to be the adjacent, 1 would have to be the hypotenuse. Using Pythagorean theorem, as we've seen this before, I'm going to have the root of 1 minus x squared. Okay, now that I've done that, I can set up the formula. Sine of s cosine of t plus cosine of s sine of t. So I need to do sine of s, so sine of pi over 6. Sine of pi over 6, which is sine of 30, is 1/2. Cosine of t, so we revert here, cosine of t is x over 1, so it's just x, plus cosine of pi over 6. Cosine pi over 6 is root 3 over 2. And now I need sine of t. Sine of t opposite over hypotenuse, which means it's just going to be the root of 1 minus x squared. Okay, let's try to simplify a little bit. Multiply these together, so I get x is equal to 1/2 of x plus, simplify here, multiply what's inside radicals, so I get 3 minus 3x squared over 2. Now I'm going to try to solve for x. We'll subtract 1/2 x. So I get 1/2 x. Is equal to 3 minus 3x squared all over 2. In order to get rid of the fractions, I'm going to go ahead and multiply everything by 2. So I get that x is equal to 3 minus 3x squared. Now I need to get rid of the radical. So I'm going to square both sides. Note, if you square both sides, you have to check for extraneous. Okay, so if we square both sides, we're going to have to make sure to check for extraneous solutions at the end. From here, I'm going to go ahead and solve. Add 3x squared to both sides. I get 4x squared is equal to 3. I divide by 4. Continue it right here. So we're going to keep scrolling down. X squared is equal to 3 over 4. Square root. If x is equal to plus minus root 3 over 2. So my choices are, it can either be root 3 over 2, or it could be negative root 3 over 2, or it could be both. So now I'm going to clear the page. I'm going to reopen that question. And we're going to look at root 3 over 2, and we're going to look at negative root 3 over 2. We're going to plug them back into the original. So I need arc sine, and I'm going to start with negative root 3 over 2. So I need to know arc sine of negative root 3 over 2. Well, remember that arc sine is in, if we're talking about negatives, arc sine is in fourth quadrant. So here's our negative root 3, here's our 2, here's our 1. Okay, so what angle would this be? Well, this could be looked at as, we know it's some variation of 60 degrees, but we're talking about in radians, so it's negative pi over 3. Or if we wanted to keep everything in positives, we could say if we went all the way around this way to get there, we'd be looking at 300 degrees, which is root, not root, 360, so 2 pi minus pi over 3, which would leave me 5 pi over 3. Doesn't really matter, should come out the same way, either way you work the problem. But I'm going to do them both just so we can double check ourselves. Now, arc cosine of a negative, I'm going to draw its picture up here. Arc cosine can only be negative based on the rules we were given in this chapter in second quadrant. Because here's our negative root 3. That means this is 1, this is 2. Here's theta. What angle is this? Well, across from 1 we always know is some version of 30 degrees, which is pi over 6. And if we're going this way, then we're talking about going over an 80 degrees, and we're subtracting out 30 degrees, or since we're in radians, we're talking about pi, subtract out pi over 6, that's going to be 5 pi over 6. Okay. Or if we're talking about going the negative route, going this way, since that's the way we did with the first one, we're talking about pi plus, or negative pi plus a pi over 6, so that'd be negative 7 pi over 6. Okay, so either way we go, this is our negative route, if we go that way, or if you want to keep it all in the positives, we're going this way. We need to have common denominators, so we're talking about 10 pi over 6 minus 5 pi over 6. Well, that's still 5 pi over 6. So that one does not work. Let's check this one. Making this in terms of 6, that's negative 2 pi over 6. And negative negative makes positive, plus 7 pi over 6. That's still 5 pi over 6. Either way, we got the same answer, whether you went negative route or positive route. But either way, negative 3, negative root 3 over 2 does not work. These do not equal pi over 6. And one more time, since we still got one to look at, root 3 over 2, plug those in. Okay. All right, thinking about this one, thinking of first quadrant, So there's arc sine going across from the angle theta to root 3. That is 60 degrees, or pi over 3. And then, I'll start right here. Arc cosine, we can go from the same one. Moves around a little bit though. Root 3 is here. Alright, now that I've got this picture, this is obviously some version of 30 degrees, or pi over 6. Now let's go ahead and make them common denominators. I got 2 pi over 6, subtract a pi over 6, which gives me pi over 6. So this one is correct. So the only answer, only answer for this question would be root 3 over 2. The other answer, negative root 3 over 2, was extraneous. Alright, 2 questions left and then we are done with chapter 6. These are both graphic questions, so we're going to look at Desmos for these. It's wanting you to basically do what we've done before. So I'm going to type in that I'm actually going to use their functions here. I have arc sine of x. Let me zoom in for arc sine of x, that's what it looks like. And then I need 3 pi y equal 3 pi divided by 7. And just in case, just so you can verify to make sure you're using the right one. Looking at x here, x does not even touch the function. So if you did x equals 3 pi over 7, you would not actually touch the function. Y being 3 pi over 7, there is one intersection point, and it is 0.975 radians. So 0.975 radians. And then let me look at the second question, is arctan squared. So now I need functions, I need the arctangent, so that one, of x. And I'm going to put the whole thing in parentheses so that I can square it. Okay, so there's arctangent squared. That's what it looks like. It looks like a weird U shape, kind of like cosine. And then I need that one to be equal to 0.73. Now notice on the arctangent, there are 2 places that arctangent squared would be equal to 0.73, and that is at negative 1.148 and positive 1.148. So 2 spots. Okay. Well, that is the end of 6.4, which is the end of chapter 6. And so the only thing you have left to do now is look at your practice test, do your homework, and prepare for chapter 6 test.